Welcome to 24 Hours of Pass, the Summit Preview. We're excited you could join us today for Scott Curry's session, Create and Load a Staging Environment from Scratch in an Hour with Biml. This 24 Hours of Pass event consists of 24 consecutive live webinars delivered by expert speakers from the Pass community. The sessions will be recorded and posted online after the event. To access any on-demand sessions, please visit 24hoursofpass.com for all session links. My name is Hamish Watson. I am from Christchurch, New Zealand. It's currently 1 a.m. in the morning, but this session is one of the few sessions that I'm really looking forward to seeing. So that's why I'm lucky enough to be moderator for it at 1 a.m. in the morning. I'm a Pass user group leader and a DevOps evangelist. And part of the things that Scott's going to talk about today, I think fit into a deployment pipeline. So I'm really looking forward to this session. I have a few introductory slides before I hand over the reins to Scott. Alrighty. If you require technical assistance, please type your question into the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the section, I'll read your questions aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. Okay. I'd like to take a moment to thank our presenting sponsors, Quest, Melissa, and Nutanix. The staging of 24 Hours of Pass would not be possible without their generous support, and they are the reason this event is available free of charge. Right. Make sure you explore everything else Pass has on offer for data professionals. You can join local user groups around the world, special interest groups, find free online resources through our Learning Center, and read up on the latest community news in the Connector newsletter. Okay. Next, I'd like to bring your attention to the upcoming Pass Summit, taking place in Seattle, Washington, USA, from 31st of October to November 3rd. Pass Summit 2017 features over 200 sessions with world-class data experts. It's the perfect place to connect, share, and learn from industry experts from around the world. To find out more, please visit www.passsummit.com. And without further ado, here is Scott with Create and Load a Staging Environment from Scratch in an Hour with Biml. Over to you, Scott.
Thanks, Hamish. So you think we're going to do it in a little less than an hour today, which is great. We're going to leave a few minutes to answer questions at the end. My name is Scott Curry, and I am the CEO of Verigence, also the creator of Biml. Notes here, I have worked with a large number of people, both those working for Verigence and those who are members of the community, and we've, I think, done a great job together as kind of an extended team. But of course, since I was the first one there, I get most of the credit and occasionally the blame if things don't work out the way folks like. Previously, I worked on compilers at Microsoft. For those who are seeing Biml for the first time here, that'll probably make sense as a previous experience before working on Biml. Biml essentially is a compiler. It has, in addition to the compilation of the flat Biml XML code into SSIS and other types of objects, we also have these little nuggets of C#, or if you prefer VB code, that you can use in order to automate all of that. So very much is a compiler technology, and this is just a compiler technology targeted at data development as opposed to app or web development. And when I'm not working on Biml and other things technology related, I spend as much time as possible with my family. 8 is enough for now, at least. My wife and I together enjoy 5 wonderful children and 3 mostly big dogs. We prefer them large. We have our biggest is a 120-pound Emperor Doberman. So it's almost like having another person in the house. If you want to reach out to me, I am not on Facebook. Turns out that took up a tremendous amount of time, so I ended up deleting it a little while ago. But you can reach me on Twitter at Scott Curry, or I am Scott R. Curry on LinkedIn. So today we're going to be getting out of slides very quickly here. We just have a couple of slides so I can give you an overview of what we're going to be looking at, and then it's all live typing. And in fact, I've got one of these very loud, clicky mechanical keyboards, so that'll keep me honest that I'm actually typing and not, copying and pasting or playing videos or doing some other sort of trick. So what we're going to do after we have an initial just overview of here's what the Biml workflow looks like is we're going to build out a staging environment. So we're going to start from scratch. What that means is we're going to have a connection string to a source. That's what we start with, and a connection string to a target database that we want to stage that data into. And from that, everything else is going to be written in code so that it's entirely reusable. We're going to have code that inspects the schema of the source system and creates a almost matching schema on the target system. We don't want it to exactly match in all cases because we might want to change table names or add metadata columns so we know the last time or at what time a given row is loaded. We have a lot of options for things that we might want to enhance our source schema with in our staging environment. And then once we've created that schema, we're going to want to create packages that are going to do the load of the data from the source into the target. Oftentimes we'll, at the end of this session, especially if it's a smaller group or if it's in person, it's kind of easy to go out to the audience and say, hey, any questions? Would you like to enhance things a little bit? If there are some requests to, hey, could you do, this particular sort of modification, I might be able to go ahead and live type that up for you depending on how much time we have and how simple the request is. Barring that, I'll show you a couple of things at the end around, to Hamish's point, how you could start to automate this a little further and, for example, write your SQL scripts out to files that you could check into source control that you might be able to then use from an automated deployment system. So we'll hit that end instead of the live requests at the end if we don't have the request coming in. Okay, so just as a visual overview of what I already discussed, we're going to start with our source system and what we're going to create, our schema for the staging target, then the load packages, and of course we're going to even run it so you can watch the data load and make sure that it all works. How are we going to do that? We're going to do it with Biml script. So the way Biml script works is that you will write some code, and we'll see how this works in our handy editor inside of Visual Studio or SQL Server Data Tools. We have an extension for SQL Server Data Tools called Biml Express. You install that, you start typing your Biml code into your new Biml files, and then we have some right-click context menus that allow you to build them out. So this is kind of an important point between developer code and shared scripts. The first project you ever do, think of it as developer code. It's one-time use, but as that one-time use code becomes mature, it covers more cases, you might be able to take that code and start using it across more than just one of your projects. And that kind of becomes part of your tool belt that you can use on any project that you walk into. So that's where the shared script point comes in. It's such an important part of the overall Biml workflow, being able to reuse that code in a way that is almost impossible to do with the native SSIS design experience, that we actually put it on the top level workflow. We expect people to be able to build that reusable code over time. So that goes through the Biml engine, and what the Biml engine spits out will be T-SQL, SSIS, and potentially other objects that you can run directly against your unmodified servers. In fact, when you look at what we spit out of the Biml engine, you can't tell that it wasn't built by hand. It looks exactly like something that you had hand built. The only real difference is you got there a lot faster in most cases. So we are going to, with that, jump in and see what it looks like. So here we have a new instance of Visual Studio, and you'll notice that I have this Biml Express menu bar at the top, menu item at the top. So how do I get that? The way I get that, I can just, in my favorite search engine, type in Biml Express, or I can go to Verogens.com. Right here on the front page, single click. You don't even have to go read any of the material on Biml Express. You see where it says free download? Click it. Did I click it? Nope. There we go. Click it and you'll do a download. You'll see I've done this a few times before. Once the download completes, just run this. It's a V6 extension, which is a Visual Studio installer, is essentially what that is. So it's the installation format that is custom to Visual Studio. Essentially, it's just a zip file. So if you want to change that to a .zip and see what's inside, you can feel free. And what that does is it registers and installs the Biml Express extension into Visual Studio. So you just do that. You restart Visual Studio, and then you will have your own Biml Express menu entry up there. But you don't even have to do anything there. You could go ahead and make some changes to your options. There are a handful of different things you can do. For the most part, you're going to be happy with the options that are pre-configured for you. So we're going to go ahead and hit New Project, and I am going to put this in my 24 hours of pass folder, and we're going to call this Staging Loader. And now I will hit OK, and we get a new project. So once we do this, and the real first thing to notice is that nothing here has changed, right? We have the exact same layout that you normally would expect from a project in SSIS. We've got our package that's pre-populated. So where's all the Biml stuff? To get started, generally all I'm going to do is right-click here at the project level and say I want to add in a new Biml file. Okay, so I do that, and we'll see that my Biml file opens, and I have under my miscellaneous folder a new Biml script. Now this is something that's potentially confusing, especially after you've added a few Biml files. You're going to see them down here, and you're going to say, well, I want to right-click miscellaneous and do add Biml file there. Can't do it, and it's not because we didn't think that was a good idea. It's because the way the project system for SSIS is structured, there isn't a context menu that we can bind to add items to. So we're stuck. You have to just always remember to do it up there at the top level, or you can also add a toolbar up here if you do it very often. Those commands are exposed to you through Visual Studio if you want to customize your toolbars. Okay, so when our file opens, you'll see that we have the same code repeated one right after the other. And at first this might seem odd. Why do I have these two windows? You'll see how useful this is in just a moment. If I start typing here, you'll see that I can now add in a variety of different things. I have connections, I have databases, I have packages, I have schemas, I have tables. We'll use all of those. A couple of things to look out for. There are some things like cubes and tabular models. The Biml language can do things that aren't included in Biml Express, and that's what those are for. So you may not be able to use everything in here with Biml Express, but you can use almost all of it. Script projects, if you want to do script tasks and script components, all of that's supported by Biml Express. So what we're going to do in order to create our staging environment is we're going to start by creating some connections. We said that earlier. We needed to have a source connection and a target connection. Where are we getting our data from, and where are we putting it to? So we create connections, and you'll see we get this handy editor advice as we're typing that helps us find out what our options are. And definitely lean on these completion lists and also the quick info, where if you hover over any node, it'll give you some documentation about it. So I am going to be using OLADB for this. So here we have OLADB connection, and I'm going to have a name for it, and I'm just going to call this source. It's my source system, and then I have a connection string. In connection strings, I have a little save me project here just in case I make mistakes. I can never remember the syntax for connection strings. I don't believe I am alone in that. So I am actually just going to copy and paste that if nobody objects too strongly. And what we have here is just a simple connection string that's going to use the SQL native client provider. It's going to be connecting to localhost. I could have put dot here also. I have a little test database I use called Data Patterns that has a bunch of tables with a bunch of different data types in it, but it's a little bit smaller than AdventureWorks, so demos go a bit faster, especially resetting demos and deleting things between runs. And I'm going to be using Windows Authentication to access it. And that's it. I've got my OLADB connection, and I do have to remember to close that XML tag. If you're not familiar with XML, you don't always have to have a open and a close tag. If you don't have any child elements, I can just put a / angle bracket at the end, and that closes the tag all in one step. The next thing that I'm going to do is close that SSIS toolbox so I have a bit more view space, and I'm going to add in a new connection. One thing to note in the completion list here is I don't have to type starting at the beginning of the word. I can start typing connection, and you'll see that it actually will filter in the middle of the word too, which is a nice feature. And I'm going to say name is equal to target. My connection string here is equal to copy paste that. And this is something that should be interesting to folks as well, where especially as we continue walking down this path, you'll see that even just having the text editor support here is kind of a win for even doing simple things like copy paste and being able to rapidly see what things I need to change and to change them in place over a drag and drop GUI in a lot of cases. So many folks, even if they don't make too much use of the scripting capabilities, still really enjoy the experience of being able to type. That's not going to be everybody's preference, but for those who enjoy typing rather than dragging and dropping, it's a great experience. So we're going to have a database that we've already created here, data pattern staging, we'll go ahead and call it, and it's going to have a target. Now, this database and schema that I'm creating, this is an in-memory object where we don't have to deploy our database and schema from here. I know normally that's an ops function. This is just something that's an in-memory representation of the database that we will be deploying to. So this is just the little bit of sort of bookkeeping that we need to do before we can get into the meat of our application. Instead of typing out data pattern staging, I'll just go ahead and copy and paste it, just like that. So that's it. This is our environment file. And this is kind of a great thing to have because this environment file has all of our configuration information. If we ever want to retarget this solution at another source system, all I have to do is change this environment file. I'm not going to have to change any of the other code that we're about to write. And in fact, if I wanted to, I could instead put this environment information in the database, and I could pull that data, this environment data, from my metadata database. Right? And I would just, instead of coding this out directly, I would use code nuggets to connect to the database, which will, you'll get an idea of how that works in just a moment. So I save that off, and as you've been noticing here, this is, when I save it or if I click update, it will actually just show me in the bottom pane exactly what I had in the top pane. Now that isn't interesting for flat files, and in that case I might just, for files without code nuggets, I could hide that preview. This is going to be very interesting once we start adding code nuggets and generating a lot of stuff automatically. So that's our environment, and I am actually going to take this Biml script file and I'm going to rename it to environment. Now there's a naming format. I'll explain this a little bit more later. But oftentimes you need to do multi-step builds where first I need to do a build that's going to create, let's say, the DDL for this target schema, and then I'll go ahead and deploy that, and then I'll build my packages once that schema is already in place. So if you have a multi-step build, this naming format can be very useful, where essentially each of these numbers is going to indicate whether or not it participates in that build step, and if it doesn't participate in the build step, you put an X there instead. So I actually just explained it, but you'll see how that works in action in just a moment. So now that I have my environment set up, I am going to go through and create my my target schema. So this is where it starts getting a bunch more interesting. I'm going to add another Biml file, and this Biml file is going to start with Biml as well, but I'm going to have some tables in there. And the tables are going to be structured kind of like this. I'm going to have a table. It's going to have a name. I don't know what the name is yet. And I am going to have that table living in a schema. I do know what the schema is. The schema is going to be called data patterns staging.stg. That's the schema that we created earlier. And we know that this table is going to have some columns. If I wanted to define some indexes or other information, I could do that all in here. But since this is a staging target, really I just want the data, and I'm going to have columns, and that's it. So now that I've kind of scaffolded this out a little bit, and by the way, if I wanted to add in columns, I could go ahead and do that, and we support all the stuff that you need to set up your tables the way that you would want to. We have pretty good fidelity with the things that you can do in SQL Server, and 100% fidelity with everything you can do in SSIS. For the things that we don't expose in Biml as an option that SQL Server might support, you can always go back to just writing DDL for it. So you've always got a way to get down to the bare metal with your Biml solutions. So now that I have this kind of scaffold, I know that each of the staging target tables I want to create is going to look kind of like this. I need to go and inspect my source system and actually fill these out correctly. For each table in my source system, I want to have an equivalent table in my staging target. So for that, we're going to start using code nuggets. And our code nugget syntax looks like this. We do a bracket pound. Any code nugget is going to start with bracket pound, and then we have some other types of code nuggets that we'll see in a second that are kind of specializations of that syntax. So I start off by, and our default is C#. If you wanted to use VB, that's totally fine. You use a bracket pound at as a directive, and then you would be able to say, I want to have a template, and I want my language for the template to be VB. And in fact, you can even choose a specific version of VB if you want to lock yourself down to specific language features. But we're going to use the default, which is C#. And the first thing I need to do is get my source connection that I've already defined in my environment file. I don't want to have to write that connection string again. So I'm going to say source connection is equal to root node. So root node corresponds to, of all the objects that you've created in all of your other Biml files, root node is the anchor for that you start from. And the cool thing about root node is it has one-to-one parallelism with everything that you can do in this Biml node here. So Biml has a tables collection, so does root node. You'll notice that we are getting completion lists on the C#. That is a feature that we just shipped in our latest version as a preview feature. It works pretty well, but we don't want to put it out there for everybody just yet. If you want to get access to that and you have to promise to give us feedback, go ahead and send us an email at support@urgence.com, and we can actually enable it for you on your machine just by giving you a license key or enhancing your license key with a flag to say that you have access to that feature. But as you can see here, we have for each one of those Biml collection tags, we have a collection in here. So I want to go ahead and grab tables, connections. And I'm actually going to use DB connections, which was one of the other options there. We don't have a tag for that, but we have these convenience collections that allow you to pre-filter things, so you don't have to go through and maybe grab from a list that's this big. It gives you just the connections to databases. And I am going to grab the one called source. Each of our collections in Biml is both a collection that you can iterate over, and it's also a dictionary that you can look things up in by name. So I'm going to grab the source connection, and then once I have my source connection, and this line of code is really powerful, I am going to import the schema. So I'm going to say import result is equal to source connection dot, and we have a couple of different APIs for this. We have one called get database schema. I'm going to use one called import DB because it's the one that's used in the sample for this online that's already published. They have slightly different options and they work a little differently. Import DB does the equivalent of a select star in every table and gets the metadata for it. And get database schema goes and uses the information schema tables. And you sometimes get different type mapping results from those two, and that's why we provide both. So these are filters saying, do you want to filter down the list of schemas or tables that you get? Nope, I want all of them. And then I can also put in some options. So I'm going to say import options dot exclude foreign key, and I'm also going to do import options. You can see the IntelliSense isn't perfect yet. It's saying no results, even though it should have some there. It's the reason why it's not generally available yet. Exclude column default, and that's just saying don't bring in the column default information because we're not going to have column defaults in our staging environment. And then the last one is views are great, but I'm not going to stage them here. So import options dot exclude views, and that's it. At the end of this line of code, after line 3 runs, I'm going to have an import result object, which is chock full of all the schema information that we're going to be using to build our target tables. So let's use it. This is where it gets real fun. I put in a second code nugget here. And now what I'm going to do is say, I have this import result. Let me grab the tables out of it that we imported from our source system for each var table in import results dot table nodes. And then at the end, so my code nuggets can actually span this plain text. So I can begin a loop up here, and I can terminate it down here. So for each iteration, for each table node it finds, it's going to go ahead and loop over this and spit out whatever code's in here. So now I want to customize my name. We've seen the bracket pound syntax for what we call control flow nuggets. We also have these things we call text nuggets. If I put a bracket pound equals, it'll take whatever expression goes in there and it will do a toString on it. So in our case, what we're going to do is table.name But notice we're putting all of our target tables in the same STG schema, and that's by design. We don't have to worry. We don't want to have to worry about all of the schemas that we might have on the source system. We just want to shove everything into the STG schema. So we're going to need to make sure that our table is named appropriately so that we don't have collisions between same name tables in different schemas. So I'm going to, instead of just saying table name, I'm going to say table.schema.name. So our object model that you have that you can work with, this object model is the Biml object model. Right, so all of the things that we're defining here in the XML, you can access through the object model as well. Biml's what's called a homo-iconic language. So that's just compiler geek jargon for homo meaning the same and iconic meaning representation. It just means that for every single language element, we have an API element. We have a property in the language, we have a corresponding property in the API, and they're usually named exactly the same thing. The only difference is things like schema name, right? That's a reference. So instead of being schema name in the API, it's schema. And then you have the whole schema object where you can grab the name and other things as well. So there we have our table nodes. And before I go further, we actually have enough code to run now. So I have one of my options is update on save. So when I save this file, my update window is going to update. It compiles the Biml in the background and, oops, did it not pull that out correctly? Let me see if, update. There we go. So we have all of our tables, addresses, address to, and other stuff. But that's not useful yet. We're not getting our columns in there. So let's get some column information in. I noticed, I mentioned earlier that Biml is what's called a homo-iconic language. It's a one-to-one mapping between the API objects and the XML language. So wouldn't it be great if we could quickly move back and forth between them? Well, actually we can. So part of the Biml engine is we have a parse method that you can call at any time and hand that some text and it'll spit out objects for you. We also have this thing which is far more useful in practice than the parse method. It's the getBiml method. So I here can say table.columns. And the great thing about the getBiml method is you can call it almost anywhere. You can call it on individual objects. I could say table.getBiml and it would give me the Biml for the whole table. Or I could say table.column.getBiml for a specific column. Or I can say for a collection of columns, table.columns.getBiml. And watch this. I save it. And there we are. I have all my columns from the table with all the length, precision, scale information, nullability, everything we need. So you might just be wondering, oh, well, wait a second, Scott. Why is it that you didn't just say table.getBiml or something like that? Well, the answer is that we want to make changes to the target schema. Target schema is close to the source schema, but not exactly the same. So like, for example, I might want to name this table stage underscore, right? I might want to, instead of just saying columns getBiml, I might want to say for each var column in table.columns. And then down here, say instead of table.columns.getBiml, I can say column.getBiml, right? And this is the equivalent. I just wrote the exact same code, right? This is just using the one-by-one column approach. But then we can go one step further and we can say, well, maybe I want to make modifications along the way. And I know it's a philosophical debate as to whether or not you should make any changes like this when you are operating in a staging environment, or is this something that should always be done downstream of staging? But we can do things like if column.dataType is equal to, and we use system.data.db type for everything, system.data, or for everything that we can, and then we have additional custom typing when you need to. You could say if this is a string, let's say that you're staging from Oracle, and Oracle supports Unicode string lengths that are larger than 4,000, right? So if column.dataType is equal to string and column.length is greater than 4,000, then do something custom. Otherwise, just spit out the column. Right? And then in here, I could put in, I can mix and match the hand coding versus, or the flat text coding versus the object coding. Right? I could say the name is going to be the same name column, but now I'm going to make some changes to the data type and make it an nvarchar max or do something else to it. Or you could say, if you know that your source system has some strange handling of decimal values that are either richer or less rich than your SQL Server target, or maybe your target is some other non-SQL Server database that you want to do some specific type mappings or other modifications to. All of it's there. Basically, if you could explain to me or you could explain to some other developer what you want that type mapping logic to look like, you can encode it as an algorithm and you can write it down as Biml. So I'm not going to dive into that too much. We can double back on it if people have specific questions about how to handle it. I'm going to keep it a bit more simple just for the current approach. So here we're at 17 lines of Biml code plus 12 lines for our environment. So we're under 30 lines total, and we already have our staging target environment kind of configured and ready to go. But Biml objects are not database objects, right? We need to get this to the database somehow. So how do I do that? Well, the next thing that I'm going to do is actually just rename this. I'll call this create table metadata. That's essentially what these are at this point, metadata objects. And then the next thing that I'm going to do is actually deploy that metadata table information. And there are a couple of different ways I can do this. Historically, the way that we would often do it is actually put the DDL inside of execute SQL tasks, and then you could deploy it that way into a staging environment or something like that, and then you could use, or a build environment, and then you could use various compare tools to do deployment and stuff. That's one way that a lot of people like to do it for some time. These days, especially with the preview window, we have some additional options. So here I'm going to call this deploy target tables, and instead of doing any SQL coding in here, what I'm going to do, and this is actually only needed for step one. Once the tables are deployed, we don't need them to be built out for the packages. So I'm just going to say 1-x for that. We're only going to use it in the first step. So I'm going to say deploy target tables, and the way this is going to work is as follows. I am going to say for each var table in root node dot tables, and I said we had this API available to us. We have a whole bunch of helper methods in the API also. So in addition to the things that we expose that are language elements, and in addition to those convenience properties that we expose, like DB connections that we saw earlier, we also have a bunch of utility methods that make your life easier for common tasks. So I can say, for example, table dot, oops, let me get that out of the way, table dot, it's get, drop, and create DDL. And now if I hit save on that, actually, we're not going to get a result here. One quick note on the expansion functionality here. Our expansion functionality depends on what files are open. So there are two things we're going to have to fix here for this to actually work entirely. The first is that we need to make sure that our previous file here that I had already closed is open. So create table metadata, because the live preview, think about it this way, right? Let's say I had 100 files in here that were doing different things, and I created tables in one file, I created tables in 3 other files, and then I have something that iterates over the tables. Well, which tables should it be showing me? It'll show me the tables that were created in any of the files that are already open. If we don't do it that way, we'd have to be like background compiling all your files all the time. We tried that. The performance is not suitable for most folks. Make sure you have your stuff open. The other thing that you need to do, and you'll see that in just a second, you'll notice we're not getting any tables in here. And the reason is that you need to tell us something about what order to run this stuff in, right? So if I have an environment file, which is got no script, and then I have this create table file that has script, and then I have this file that has script, well, this script is creating tables, this script is consuming the tables. But how does the Biml compiler doesn't understand your code? So how does it know that it should run this one first? I mean, clearly it has to, right? These tables have to exist before you can iterate over them and do something interesting with them. What we have for that is the ability to define tiers. So I can say in a compiler directive here, template tier equals 2 or 200 or whatever. The default tier for Biml script code is tier 1. So tier 2, make sure that this will run after, and there we go. Once I put it in tier 2, I get all my Biml code out. Here I get my drop and create DDL for all of these staging tables that I just created. And now all I have to do is just copy and paste that. And as I mentioned earlier, we're going to double back on this later and see how we can automate that a little more so you're not copying and pasting things into your SQL Server Management Studio or whatever your favorite tool is for running queries. So just to do a quick refresh here so you can see that I'm not cheating. I'm always paranoid about people think I'm cheating on demos. So we go ahead and paste that in there and execute. And there we go. Now we've got our target environment set up. So for each of our data patterns tables, we have a table over here. And if I had customized them, all the customizations will come through. You'll see that they're all in the SDG schema, and they're redundantly also named with stage at the beginning of them. So far, so good. By the way, you can see some of the benefits that you get from this automation here. Like if we went ahead and reviewed this solution with our team or with our architect and they said, hey, I don't like the stage name, get the stage off the front. I mean, literally all we do is that, we delete that and we rebuild and that's it. We just made the change to, doesn't matter if we have 5 tables or 5,000 tables. We just made the change to our pattern and applied that pattern globally. So that's it. Now we've got our target environment deployed, and the last step that we have is to create our packages that we are going to use to load the data from the source system into the target system, into those target tables we just created. So I'm going to go ahead and add one more new Biml file. And this one I'm going to only do after that tier where we have deployed the target table. So x2 dash, and this one can be called, let's say, create load packages. And now we get into SSIS mode. So I am going to create some packages here. And my packages, I'm going to have a package whose, let's get confused. Just to make sure the IntelliSense is going to work correctly for me here, let me just reopen that file just in case we've got an issue there, so we can look at nice correct IntelliSense. And this is because I have the .NET IntelliSense mode on. You guys shouldn't have that experience if you don't have it enabled. As I said, it's a preview feature, but I think it helps for demos so you can see what the object model looks like. So I am going to have a name for each of my packages. And we also have some all the different features on packages that you can have inside of your own SSDT environment. So there's 100% fidelity. Back when SSDT was still called BIDS, we could say if you could do it in BIDS, you can do it in Biml. Unfortunately, it doesn't have the nice alliteration of when you can do it in SSDT, you can do it in Biml. But that's not our choice to make on Microsoft branding. You can see all the different options that you have here, and we even have a couple of other options that we add that we'll see in just a second, like constraint mode, but we'll get to that. And then once I've created my packages, I'm going to have some tasks. And before I dive into that, just to make it clear, because a lot of times the first questions people have is they'll think about their own packages and they'll say, oh, can you support log events and log providers, and can you do event handling, and can you it's all there, trust me, it's all there. Can you do custom components? Yeah, they're difficult, but you can do them. So I can say tasks, because for custom components you have to know what the internal layout of the data of the custom component is. So I'm going to say tasks. I'm going to put in a data flow. And the data flow is going to have a name, something like load table. And let me just clear out our little helper windows over here. Get my mouse into this window. There we go. And spell that right. Load table, all the options that are available on data flow. We're not going to use any of them. And then we're going to have this thing called transformations. Transformations just mean components. It doesn't mean you don't put your sources and destinations in there. That's something we'd love to rename in the language if we could, but the language has been around for so long that it's too difficult to do that at this point. So we're going to have transformations. We're going to have an OLADB source, and this is part of where the filtering comes in. I can just type in source, and there are all my sources, right, if I wanted to browse them. So I can say OLADB source. This is going to have a name. We'll say extract. And notice what I'm doing is the same thing I did with tables here. I'm not writing the full code yet. What I'm doing is kind of scaffolding it out, right? And then I'm going to go and fill it in with the code nuggets in just a moment. So I've got my OLADB source, and let's say that goes to, we're going to call that extract, and our connection name for that is going to be source. That's running against our source system. And then underneath our OLADB source, we have a bunch of options for how we get our source query. We can do column mappings, by the way, various overrides on our data flow. We can have direct input. That basically says I'm about to type it in for you. We can say external table input. That means I'm going to give you the name of a table on that that you can find at that connection string. You can say I'm going to give you a variable name to find it. You can say table input. Table input is where we've already modeled a table like we did with those staging tables, and I just want to reference it by name within the Biml object model. Variable input, where the variable will contain a query as opposed to a table name. And then you can also do parameter mapping and everything. It's all there. So here I'm going to do direct input, and we're going to, and before anyone jumps down my throat, we're going to fix it in a second. I'm going to do an anti-pattern, select star from some table name. And once I've done that, there's my OLADB source. Now I also want to have an OLADB destination. And my OLADB destination is, oh, and the reason the IntelliSense is wrong now is because I didn't close that out. Here we go. My OLADB destination name is going to be, let's say, load. And my connection name on this one is going to be my target connection. And then in here, I need to tell it where I want it to load to. And this is going to be, in this case, I could do the external table output. I am actually going to do the table output. Our target for this is going to be the table named whatever our table name is. We're obviously going to add an iterator in there. So I have these placeholders that I've created. So you may notice that I didn't actually draw an input path between OLADB source and OLADB destination. What's the equivalent of dragging that line that I would in the design surface? Well, the answer in Biml for convenience is that if there is a clear default output of the OLADB source and either a single input or a default input on the destination, we just do them in lexicographic order. So whatever order you write them in, there's an automatic line placed there. That's obviously work because for data flows, those connections have to exist. For tasks, we don't do that for you automatically unless you tell us to. We have a way to do that in the task structure as well, but it's not as automatic because tasks can easily be parallel as opposed to being sequential. But you're literally just not allowed to have a destination, an OLADB destination, where its input path is not bound. So we can do this sort of stuff safely. But if you ever wanted to override it and say, hey, I've got this input path and here's my output path, and I'll just tell you which component and which output path to use. So you can do that stuff manually, but we'll do as much of it automatically for you as is possible and reasonable. So now that I have this configured, what I'm going to do next is add in my nuggets. So just like we had before, we add in our template tier is equal to 2. And by the way, in case you're curious about it, these template directives and our other directives don't have to be at the top of the file. You can put them at the bottom if you prefer to see them down there. You have a lot of freedom. And also, while we're on the subject, you have many different options. So you can reference code files. So if you had like a C# or VB file that had a bunch of utility methods in it that you'd like to call, you can just go ahead and reference that by path right there. And you can do things like global includes. There are, so I can have like one file that has a whole bunch of directives that I'm going to be using every place, or code that's going to be shared across all my files. I can put that in a global file, and I just mark that file as being global, and then it's consumed by all my other files. Import, if I want to bring in a namespace that I'm going to be using, it's the same thing as a using statement in C# or an import statement in VB. I can even reference assemblies if I have let's say I want to pull data from Dynamics CRM. So in my source system, instead of being a database, is Dynamics CRM. I could use the Dynamics CRM SDK and just reference the assembly for it here, and then start calling that code to go ahead and inspect the schema, find all the entities and attributes in my CRM system. So all that stuff, like if you can think of it, if you can think of a way to automate it and get at it through a .NET object model, you can do it in Biml code. We're really just scratching the surface in this first hour. And you may be looking at the time and wondering if I'm going to be done. I'm, going through this stuff. I've got plenty of time. We're going to be done here in 5 minutes. So next step is to bind this up to our target tables. So I am going to put in a for each var table in root node dot tables. And then I'm going to wrap that down here at the bottom of the package. And once I've done that, I'm getting a package per table. Here I can name my package whatever I want. I'll call it copy or whatever. And now I'm just going to say bracket pound equals, and I'm going to say table dot. You know how we have name? We also have this thing called scope name, which is a fully qualified name. It's very much like a multi-part name in T-SQL. So if I had two tables that were in different schemas, that would give me the schema name and the table name. So in this case, since we are sure, because of the way we've constructed our tables, that they're all in the same schema, we could just get away with name, but it's safer to do scope name. So if someone changes something in those upstream files later, this code still works without modification. You may notice that there will be illegal characters in here potentially, like dots and whatnot. We will auto scrub those. We'll give you a warning, but we'll auto scrub those names for you. If you want it to just be explicit about it, we also have something called SSIS safe name, where it's pre-scrubbed for you, or SSIS safe scope name. So if you're the type of developer who just doesn't ever want to see a warning, you can use those and be explicit about the fact that you know the name is being scrubbed. So we're going to be copying that table, and then the next thing that we're going to do is just fill in our missing pieces. So instead of select star, actually let's do this one first. Instead of saying table name, we're going to say bracket pound equals table dot scope name. Give us that full fully qualified name. And our data flow here is good. The only thing we have left is to fill out this source query. So you might be looking at this and saying, all right, wait a second, I can't say select star from this table name because you changed the name of the table, Scott. So are you telling me now I've got to parse that name back out? Well, you could, certainly you could do that, but you don't have to. What we're going to do is jump back to create table metadata, and we're going to add an annotation in here to remember what our original name was, right? So instead of having to figure out what the original name was on the source system by parsing this out, we can actually just put in a little variable here essentially where we store what that original name was. Now we're not going to have to go back and regenerate our DDL. This is entirely something within the Biml object model, and it's called annotations. These aren't SSIS annotations either. These are Biml annotations, and they allow us to just associate information with our project or with any object in the Biml object model. So we also can do things like annotation types of documentation and oops, there we go when I move that. So we can say documentation, description, code comment, or we can say tag. Tag is actually the default, so I don't have to put in that annotation type. And I can say, what is the tag? So think of this as being like a key value pair. My tag is going to be called source schema qualified name. That's exactly what it is. It's the schema qualified name of this table on the source system. And what we're going to do is we're going to say it is the same as table dot schema qualified name. We even have a handy little property for you that gives you the schema qualified name. So this right here is the schema qualified name of the, oops, there we go. It's going to store the schema qualified name of this table as it was called on the source system, and then we already know what the schema qualified name of the target table is going to be because we chose what the name of the target table is. And now if I do an update in here, by the way, we can see underneath our compiling Biml now we also have this annotation, and it says, hey, this thing, which is now called stage DBO addresses on the source system, was just called DBO dot addresses, right? Perfect. So we're going to jump back over here into create load packages, and we're going to use that. So we're going to say bracket pound equals, and now instead of doing a table dot schema qualified name or a scope name or something like that, we're going to say table dot get tag. This is how we retrieve that annotation that we just created, and we're going to grab the one called source schema. You can have as many as you want, so we have to tell it which one we want. Source schema qualified name, and that's it. So now actually if I allow this to update, we're going to see for each of my tables I have a package named this, and I have select star from dbo.addresses. That easy. Addresses too. Claim. Customer. It's all there. So I promised that we were going to fix this nasty asterisk, right? So it turns out that in Biml, we have utility methods for a lot of stuff, and one of those utility methods that we offer is a really convenient get column list right there. You can also do, if you're building like merge statements or inserts or updates, we have get column compare list and assign list so that you can very quickly kind of build out complex SQL expressions using these helpers. So I'm going to say get column list. Get column list has a variety of options here. It allows us to like put predicates and filters on here. So I could say, I could put a link predicate in here, a Lambda function, if you guys are familiar with that, to say only give me the columns that are of a certain data type, or only give me the columns that have a certain name, or exclude a certain name from it. You can also put your own aliases in front, which is useful for things like merge statements. But for us, we just want the plain vanilla version. And I'm going to go ahead and save this, and we're going to see. There we go. Select, and now we get our actual column list from the table from DB addresses. All right, so this isn't something now, though, that we can copy out and do anything useful with, right? I can't just copy and paste this Biml code and get a package out. So what we do to make that happen is we have environment, create table metadata, and create load packages. I'm going to right-click those, and I'm going to hit generate SSIS packages. Some people like to do check Biml for errors first, but I like to live dangerously. I'm just going to generate the packages. And takes a moment. There we go. I just generated all those packages. Now, one thing that I actually want to point out that's going to be an error, I know it's going to be an error ahead of time, so don't call me out on this, is when I hit start, I'm going to get an error here. It's going to say my protection level's wrong. If I go through and look at it, it says that it has a different protection level than the project. We actually do that intentionally. This is one of the only places where we do not have the exact same defaults as you're going to find in SSDT. We strongly disagree with Microsoft that you should be storing sensitive information, even encrypted in your environment. So what we have done is we've made it don't save sensitive. Sorry for that. But it's very easy for you to fix. In your package here, you say protection level equals encrypt all with user key, or you could just change it on your project. And once I have done that, I just rebuild, and it actually wipes out all those packages and replaces them. And we have an extra feature actually, which is pretty useful, where if I say, let me just go ahead and regenerate them. Generate SSIS packages, and it says, hey, we've got some existing ones there. Would you like me to overwrite them? I'm going to say commit, and keep an eye on this open copy data patterns. It closes it. So the reason why it closes it is because SSDT for a long time, it's not used to the amount of churn that Biml can put through it in terms of packages. And sometimes when it tried to reload packages, it would just crash. We reported it to the SSIS team. They made some efforts to try and fix it. But there were still too many crashing issues, so we just automatically closed the packages that you have open for you, so to avoid that crashing situation. And you can turn that off if you want in the Biml Express options. One more thing that I want to do before I run this is I'm just going to go ahead and kill these packages, because let's say I went and showed this to my architect and or my ops team, and they say, great, but I'm not running 50 packages because we're going to point this next at a database with 1,000 tables. Not happening. I want you to put all of these data flows in a single package. You might be pretty upset if you weren't using Biml, but with Biml, all you got to do is take this for loop, move it, take this customization on a per table basis, and move it into the data flow, and rebuild. Can you believe it was that fast? Now I get one package called copy all that has all these data flows in it. And in case you're skeptical, I said encrypt all. It's supposed to be encrypt sensitive. See, if we were doing one of those in-person meetings, you guys would have yelled at me for that, I'm sure. And there we go, commit. And we open our copy all up, we run it. And there we go. So that's it. We're done. I mean, it's we started at 9:05 my local time, and it's 9:55. So we need to change it to create and load a staging environment in 50 minutes. Let me make a couple of quick changes as bonuses, just to show you a couple additional things you could do. You might look at this and say, I don't want to run them all in parallel. That's going to put too much load on my server. No problem. Check it out. I can say constraint mode. Do I want it to be linear on completion or linear on success? Let's say linear on success. And I don't even have to save. When you build, it auto saves for you. And now they all run sequentially. And let's say you look at that and say, nah, I don't want them all to run sequentially. I want them to run in batches of 5 at a time. I could show you the full code for that, but it's pretty straightforward. Basically, what you would do here in your tables is you would just do a standard for loop on the outside based on the total count of tables that you have. And we have things like count. How many tables do I have? So you would say, let's say I want them in batches of 5. You do a for loop where you iterate from 1 to tables divided by 5. And then inside that for loop, you have you would put a container object, which is just a container. It's a sequence container. And then inside the sequence container, you would say for each root node.tables. And here's the fun part. We use link extensively in Biml, if you guys are familiar with the language integrated query. So you can do SQL-like operations on top of .NET collections. We didn't build this. We just use it. It's great. So I can say, for example, I'd use my paging operations. So I would say skip, right? I'd skip whatever my iterator variable was, I times 5. And then it's a method dot take 5. There you go. And then what I would be doing is inside my iterator, and this would just be I times 5 if I should have just written it at this point, but there you would get groups of 5, and it would take about 5 minutes to write and test. So stuff like this where you want to change your patterns just insanely quick. So you can have the choice of leave your patterns exactly the same and just change your environment and retarget it at a new source system, or within the same source system, go ahead and change your patterns and do something totally different that you could then apply to any other solution that you'd like to. Hamish, are there any questions that folks would like answered? Otherwise, I can show you one other quick thing to help with the continuous integration side of things.
We do have just one quick question. How well does Biml work with third-party connections? For example, Theobald Extract.is for connecting to SAP.
Yeah, so Theobald's a popular request. They actually put up a blog post where they show how to do that. And it's on the Theobald blog. And basically, for all of our different things that you can do here, like connections, you'll notice that we also have, it's not popping up right now. I must have not deleted all the stuff that I had in place, but you can do a custom connection and you can do a custom task or a custom component. The primary thing that is the difficulty there that you will have to work through, see there's custom task, is that you have to know how the component is laid out internally. So if you look at custom task, for example, there's object data. So the way that you would normally do that, we actually have a feature on bimlonline.com, also in paid products that I won't discuss. You can get trials and do this, where you import your package and you get the Biml code out. And if you did that for something that used that task or component, you could see what it looked like and very easily adapt it. Theobald in particular is so commonly asked for these days. We're just going to add it to the Biml language in our next major release, which will be coming out before probably right at PASS Summit. We're going to include the Theobald connector. So that one, if you can wait a little bit, it'll be as easy to use as Dataflow is. You'll just go open bracket and SAP connector. I'm not sure exactly what they call it. And then one other thing that I will show you here real quick is, because I have like 30 seconds maybe, if you wanted to take that DDL and write it out to a file someplace rather than copying and pasting, you can just use the standard .NET APIs inside of here. So I can just say system.io.file.write all text, and then I could say foo.sql, wherever I want that to live. And then I would just say here, and here's a nice thing, and there's a whole bunch of additional functionality that we weren't able to talk about today. We can say call Biml script. So Biml script can actually be called like a method through this function. And then I would just say deploy target tables. like that, and .biml. Now, if I put in a real path there and ran this file, it would go ahead and actually just write the contents of deploy target tables out to whatever path I specified here in foo.sql. And then if you had some sort of more continuous integration system that would pick those up, or source control system, there you'd be able to store your artifacts too, rather than having to copy them out of the preview window. And there's a bunch of other tips and tricks and things like that. We've got some content on the web, and we're actually going to be doing a big content push over here over the course of the next year. But this should be enough, hopefully, to get you guys started. Hopefully what you saw here was exciting. Hopefully you saw the possibilities. A lot of folks see this at first and they're like, oh, well, all you can do is staging. You can see with the richness of the types of things that you can do in the language, and especially with the code nuggets, and especially if you tie this up to a metadata store that you have someplace, maybe even one that you created yourself, where you can annotate, hey, this table used the type 2 pattern for it, this table used something else, or like this column is a type 2 column. You can start to do extraordinarily rich things through a metadata-driven approach.
Okay.
All right, thank you, everyone. And I think Hamish might have one slide left here.
Yeah, I do. Thank you.
Okay. There's some resources that you'll see, bimlscript.com. We've got a user group on LinkedIn, and there's a great stairway to Biml on SQL Server Central.
Fantastic. Please make sure to stay tuned for our next session, writing user stories and slicing epics for Data Warehouse BI teams with Lynn Windbauer. Next slide. Oops. And thank you all for attending.